What is the deadliest predator in the universe? Not a great white shark, not a hungry lion, not even a dinosaur-killing asteroid. These are threats from our small blue planet. Out there in the cosmic void, predator takes on a completely different meaning. We're not talking about teeth or claws. We're talking about something that devours light, that bends the very fabric of reality, that can swallow 1,000 solar systems before breakfast and still be hungry. But to truly understand why this monster is beyond anything we can imagine, we first need to climb the hierarchy of cosmic titans. From the familiar to the impossible, from the large to the unimaginably vast. If you enjoy exploring the extremes of the cosmos with us, consider subscribing. It's a simple gesture, but it helps us continue diving into the biggest questions of the universe. For millennia, we looked at the night sky and saw unchanging points of light. The ancients called them gods, jewels embedded in a celestial dome. But science revealed a more violent and beautiful truth. Stars are born in explosions of cosmic gas, live lives of furious nuclear fusion, and die in ways that defy imagination. Our sun seemed immense to early astronomers. And it contains 99.8% of all the mass in our solar system. 1 million Earths could fit inside it. But in the cosmic context, our sun is mediocre, common, almost pathetic. There are stars that make our sun look like a grain of sand next to a mountain. Imagine a star called UY Scuti. If you placed it at the center of our solar system, its surface would extend beyond Jupiter's orbit. Think about that for a moment. Earth, Mars, the asteroid belt, Jupiter, all would be inside the star. If you could stand on Earth and look up, you wouldn't see the blue of the sky. You wouldn't see the black of space. You would see burning red filling the entire horizon, the surface a hypergiant star dominating your existence, like an angry god. But stars like this are unstable. They tremble. They burn fuel at obscene rates. And when that fuel runs out, they don't just die, they explode. A supernova isn't just an explosion. It's a death scream that can be seen from across the universe. In 1054, Chinese astronomers recorded a guest star that appeared in the sky and shone for weeks. What they witnessed was a star tearing itself apart, releasing more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. The remnant? The Crab Nebula. Still visible today, an expanding cosmic tomb where a star once lived. But the supernova isn't the end of the story. Sometimes when a massive star collapses, something even more bizarre happens. Matter is compressed so violently that protons and electrons are crushed together, forming only neutrons. The result, a neutron star. A neutron star contains a mass of the sun compacted into a sphere the size of Manhattan. Read that again. The entire sun. In a city, a teaspoon of neutron star material would weigh 1 billion tons, heavier than all of Earth's mountains combined. If you dropped that teaspoon, it would pass through the entire planet like a bullet through paper. Some neutron stars spin fast. Pulsars can complete hundreds of rotations per second, sweeping beams of radiation through space like cosmic lighthouses. Their precision surpasses any atomic clock humans have ever built. And then there are magnetars. Neutron stars with magnetic fields 1 trillion times stronger than Earth's. If a magnetar were as close as the moon, its magnetic field would erase every credit card on the planet and distort the chemistry of your neurons. When they release a burst, they emit more energy in 1/10 of a second than the sun will emit in 100,000 years. Surely, we think, nothing in the universe can be more extreme than this. Matter compressed to its absolute limit. Magnetic fields that bend reality. Rotations that defy physics. And yet, the universe had one last trick up its sleeve. A black hole is not an object in the traditional sense. It's a wound in the fabric of reality. When a star much more massive than our sun collapses, it doesn't stop at a neutron star. It keeps shrinking, and shrinking, and shrinking, until something impossible happens. It passes through all known limits and creates a singularity, a point of infinite density wrapped by an event horizon, the boundary beyond which nothing can escape. Not matter, not light, not information. Falling into a black hole is to disappear from the observable universe. To someone watching from outside, You would appear to freeze at the horizon, your image stretched and reddened until it fades away. But from your perspective, you would cross without noticing the exact moment. Only when tidal forces began to stretch your body like spaghetti would you realize there's no turning back. Stellar black holes, those formed from collapsing stars, have a few times the mass of the sun. They're deadly but comprehensible, even predictable within their extreme limits. Then astronomers pointed their telescopes at the centers of galaxies and found monsters. At the center of the Milky Way lurks Sagittarius A*, a black hole with 4 million times the mass of the sun. It seems incomprehensible, and it is. But Sagittarius A* is practically a puppy compared to what was to come. Astronomers discovered that at the heart of almost every large galaxy exists a supermassive black hole. Some have millions of times the sun's mass. Others are billions. And these monsters aren't passive. They feed. Gas and dust spiral into their event horizons, heating to millions of degrees, shining so intensely they could outshine all the hundreds of billions of stars in their host galaxies. These objects have a name: quasars, the most luminous objects in the universe. Jets of matter and energy shoot from their poles, extending millions of light years through intergalactic space. They sculpt galaxies. They ignite star formation. They are both creators and destroyers. And among the quasars, one stands out as king. In the 1950s, a radio survey of the sky detected something extraordinary, a signal so bright, so distant, that it defied easy explanation. Astronomers cataloged it as TON 618. It would take decades to comprehend what we had truly found. TON 618 is located more than 10 billion light years away. When we look at it, we see light that began its journey when the universe was only a quarter of its current age. We're looking back in cosmic time, witnessing a monster that was feeding when the first galaxies were still forming. At the heart of TON 618 is a black hole of 66 billion solar masses. Pause and consider that number. Our sun is already so massive it makes Earth seem insignificant. Now take 66 billion suns. Compress all that mass into a single black hole. That's what we're facing. TON 618's event horizon, the boundary of no return, is 1,300 astronomical units in diameter. 1 astronomical unit is the distance from Earth to the Sun. TON 618 is 1,300 times larger than that. Light, traveling at 300,000 kilometers per second, would take approximately 2 weeks to cross from one side of the event horizon to the other. 2 weeks at the speed of light, just to cross the mouth of this abyss. Our entire solar system, from the Sun to beyond Pluto's orbit, is only 80 astronomical units in diameter. You could throw 16 complete solar systems side by side inside TON 618's event horizon, and they would disappear without a trace. TON 618 shines with the luminosity of 140 trillion suns. But remember, it's not the black hole we see. It's the agony of dying matter around it. Gas and dust spiral inward, forming an accretion disk that glows at temperatures of millions of degrees. This disk outshines entire galaxies. Imagine approaching TON 618. Even billions of kilometers away, you would be bathed in deadly radiation. The accretion disk would shine more intensely than 1,000 suns, a cosmic furnace spinning around an invisible void. Coming closer, you would feel time begin to distort. TON 618's gravity is so intense it curves space-time around it. Clocks near the horizon would pass more slowly compared to those far away, not by milliseconds, by significant factors. At the event horizon itself, there's no wall, no barrier you can touch, just an invisible line in space. But cross that line, and the laws of physics change fundamentally. Every trajectory, every possible path through space-time now points inward toward the singularity. Inside the horizon, you would fall. There's no escape, not because of lack of speed or power, but because outward simply no longer exists as a possible direction. It's like trying to travel to before the Big Bang. The very structure of reality makes it impossible. As you fall toward the singularity, tidal forces increase. Your body would be stretched along the radial axis and compressed on the perpendicular axis. Spaghettification, physicists call it. Eventually, you would be torn into individual atoms, then subatomic particles, finally into pure energy. And what happens at the singularity? Nobody knows. Perhaps reality simply ends. Perhaps quantum mechanics intervenes, preventing true infinity. Perhaps there's a bridge to another universe. Mathematics allows possibilities, but no signal can escape to tell us. Ton 618 is the most massive black hole we've ever confirmed. But is it the final limit? Or simply the limit of what we've found so far? Theoretical physics suggests even stranger possibilities. Some physicists imagine primordial black holes, relics from the Big Bang scattered invisibly through the cosmos. Some could be smaller than atoms, but heavier than mountains. If they exist, they may be the very dark matter we're searching for. Others speculate about white holes, theoretical opposites of black holes that expel matter instead of consuming it. No evidence has been found, but mathematically they're possible. Could our entire universe have been born from a white hole? Loop quantum gravity predicts Planck stars, collapsed objects that never form singularities, but bounce back in bursts of energy. If true, black holes may not be eternal graves, but time bombs waiting to explode. And then there are wormholes, speculative bridges between distant points in space and time. Some scientists suggest black holes might hide wormholes inside. If true, TON 618 could be not just a monster, but a doorway. The quest for the most extreme object isn't mere curiosity. It's a confrontation with the limits of knowledge. Black holes test the boundaries of physics. General relativity predicts them, but within their depths, quantum mechanics must govern. Where the two theories meet, they conflict. In that conflict lies the key to the next revolution in science. The unification of gravity and quantum mechanics, the long-sought theory of everything. In this sense, TON 618 isn't just an object. It's a clue, a riddle left by the universe challenging us to solve it. Every piece of data we collect, every observation we make, brings us closer to understanding not just black holes, but the fundamental nature reality itself. TON 618 challenges more than physics. It challenges imagination. It challenges philosophy. It challenges us to ask, what else is out there that we cannot yet see? What other extremes await discovery? But perhaps the true power of TON 618 doesn't lie in its size or mass. Perhaps it lies in what it reveals about us. We are small beings on a pale blue, contemplating forces that could destroy our world without even noticing. And yet, here we are, measuring, calculating, understanding. TON 618 is a reminder of humility, of how small we are, of how vast the universe is, of how many things exist beyond our perception, beyond our understanding, beyond our horizons. But it's also a reminder of hope, because if we can comprehend something as extreme as TON 618, even if only mathematically, even if only theoretically, then perhaps there's no limit to what we can eventually know. The universe doesn't end with a single discovery. It stretches infinitely, stranger and more beautiful than we can imagine. And as long as we continue to look, to question, to explore, the frontier of understanding will always be ahead, calling us to reach it. TON 618 waits in the cosmic dark, a monster born when the universe was still young, feeding, growing, shaping galaxies with its invisible gravity. And across billions of light years and billions of years in time, we, creatures of flesh and curiosity, look back and see not just a monster, but a mirror reflecting our curiosity, our determination to know, and the infinite frontier that will always lie ahead. If you enjoyed this journey to the extremes of the cosmos, consider subscribing. It's a small action, but it helps us continue exploring the universe's greatest mysteries together.